So typically when we deal with radicals, we have what we call a square root symbol. That's what most of our radicals are going to consist of. However, they're not necessarily a square root symbol. When we see, like, for example, square root of 25, what we don't see is that there is an understood 2 here, telling us that we're trying to figure out what number times itself 2 times gives us 25. So for a non-negative number b and a positive integer n, the nth root of b means a number raised to the nth power equals b. And so this is called the index. The n is the index, and the b is what we call the radicand. So just some vocabulary stuff there. So when we try to take the square root of 4, well, my index, my little 2 that's here, there should be a 2 on the first 2 and a 3 on the last 2. My index is even, just like it is on the second one. My radicand of the first one, what was underneath the square root, was positive. The second one, it was negative. And for the first one, I was able to get a real number. For the second one, I was able to get an imaginary number. Because I can't take the square root of negative 4, at least not and get a real number. It does become 2i. However, when I start dealing with cube roots, well, a cube root is what number times itself 3 times will give you 27. Well, so my index is odd on both of these last two, because it's 3 on both of them. For the first one, my radicand was positive, and my value, my answer, was also positive. It was a real number. And when I take the cube root of negative 27, negative 3, because negative 3 times negative 3 times negative 3 is going to give us negative 27. So this time my radicand was negative, and the value of the radical was a real number. What's important to note here is that if the index is odd, you can take the nth root of any number. It does not just have to be positive. We can take the cube root of a negative. We can take the 5th root of a negative. We cannot take the 6th root of a negative because 6 is an even number. So something else that's really neat is that whenever I have radicals, I can actually write those as exponents in fraction form. So what happens is that my radicand becomes the base of the exponent, and the index becomes the denominator of the fractional exponent. So they don't do a good job of writing it over here, so I'm going to rewrite this, that the nth root of b is the same thing as saying b with an exponent of 1 over n. So if I wanted to write the square root of 25 as a fractional exponent, well, since it's a square root, there's a 2 there, I could write this as 25 to the 1/2. Well, and the square root of 25 is really just 5, so that would be my answer. I have the cube root of 64. I could write that as 64 to the 1/3. And the cube root of 64 is just 4. For the next one, I have the 4th root of 81. I could write that as 81 to the 1/4, which the 4th root of 81 is just 3. So there's actually a bunch of different ways that we can write exponents and that are considered fractions. So I'm going to rewrite this whole page, this whole level right here, because it's actually easier to rewrite it if I write it than to look at what they're saying. So starting off, for every single one of these problems, I would actually just type them in the calculator, exactly like you see them. The one thing I would encourage you to remember is that you have a fancy fraction option that you can use. If you press alpha y equals, and then the number 1 in this order, then you're going to get a box that looks like this. And I would actually utilize that for some of these big fractions that or these fractional exponents that you have. So when you type in 25 squared to the 1/4, type it in your calculator, and you're going to come up with 5. I can't see 3, so I'm going to move on to 5. 5 says 8 to the 4/3. When you type that in your calculator, you're going to get 16. 7 says 256 to the 3/4. When you type that in your calculator, you're going to get 64. And number 9 says negative, and make sure that you put that negative sign outside the parentheses. Negative 5 to the 8/3 to the 3/4 is going to give you negative 25.